Hello, I'm Dan and I am from Team 7. This is our proposal for the acoustic band in the box project. You'll be hearing from each of our team members, Ryan Dawson, Matthew Patton, and myself, Dan Rorbine. Our agenda today is to go over the problem definition and requirements and the criteria, as well as the different designs that we have chosen for each of our instruments. First off, I'll go over the problem definition and requirements. The problem definition is that there is a band, Maroon 4, that needs a couple instruments to be made for them, 3 or 4 that need to be able to play a different part of a song and also be able to stow it in a limited size container. So, our requirements are that we need to build 3 instruments, 1 percussion, 1 stringed, and 1 wind instrument. Each instrument must cost no more than $15 and be able to fit inside a 2 foot by 2 foot by 2 foot cubic container. Each instrument also needs to play a different part of the song. There are some limitations, and we cannot use any more than 10 feet of pipe of any diameter, as well as no more than 6 feet of string of any gauge material. And now, you'll hear from Ryan Dawson, who is going to be presenting the stringed instrument.
So I'd like to talk a little bit about the design of the string instrument. The body of the instrument is going to be made from a 2-gallon plastic bucket. It's going to be about 4 inches in thickness and about 1 foot in diameter. The back of it is going to be solid, and the front is going to have a hole cut in it to amplify the music, similar to an acoustic guitar. The neck of the instrument is going to be made from a 1x6 treated deck board, so it's going to be really strong. And the bridge is going to be made from a 1x1x4 piece of angle iron, so it's going to be very rigid as well. The tuning keys are going to be used bass guitar tuning keys. And the strings are going to be the D and the G string of the bass guitar. So if you see on slide 6, there's a 3-view drawing of the instrument, and it'll give you a better understanding of the design. So the strings chosen, like I said, are the D and the G string, but they're actually going to be tuned to the standard open A and the standard open D for an acoustic guitar. Now the fundamental frequency of A is 110 Hertz, and the fundamental frequency of D is 146.8. This is going to give us a good range for playing the low voice part of the song that we chose. To talk a little bit about the physics behind the string instrument, if we know the frequency and we also know the length of the instrument, we can come up with a ratio of the string tension and the linear mass density by rearranging the formula shown on slide 7. So if you look at the engineerspulse.com, you'll see similar calculations done on standard acoustic guitars. For the main justifications of this design, I would like to say that the bass guitar strings, we know they'll work. It's a proven technology. Also, the playability for being a 2-string instrument and having a short neck, it's going to be very easy to play. And the design is extremely robust. And also, we came in under budget at $12.63 for this design. Thank you.
Thanks, Ryan. My name is Matt Patton, and I'm going to tell you about the wind instrument I created for Team 7, the pan flute. For construction, I used 5 foot of half-inch Schedule 40 PVC, 5 foot of 1/8 inch rope to hold it together, and spray paint for aesthetics. Slide 11 of the PowerPoint shows you the frequency ranges I was able to create with the pan flute. The formula was quite simple. It was the note you wanted times the speed of sound divided by twice the length, which gave you your frequency. I chose the pan flute because it was light and easy to play. It also came in under budget at $6.90 to build. The biggest thing I've learned so far with creating the pan flute is to overestimate the length slightly. That way you can shave just a little bit off the end to get that perfect pitch that you're looking for. Now, back over to Dan for the percussion instrument.
Hello, my name is Dan Rohrbein, and I am doing the percussion instrument. I decided to do a cantilevered percussion instrument, and the way I'm going to do this is, if you look at the slide that I've put on the screen, it is going to have 9 pipes. It's going to be a half-inch conduit or galvanized steel, and it's going to have two 2x4 sandwiching the 9 pieces of conduit. It's also going to be short, so it's going to be playing the high voice in the alma mater song. And I'm going to pull up another slide, you'll see, and there are all the variables that I use to calculate out the different lengths of each pipe. So I'm going to go through the variables real quick. M is the first mode, and for cantilevered it is 1.194. K is the square root of the inner diameter and outer diameter squared, added together, divided by 4. And that came out to about 0.0060, or 60 thousandths. V, velocity. 6,100 meters per second is how fast sound travels in steel. Length, you will see calculated out in that table on the right side. And frequency. For the high voice in the alma mater song, frequency ranges for the different notes is between 293 Hz and 587 Hz. The formula that I use to calculate this out is L equal to the square root of pi times velocity times K times mode squared divided by 8 times the frequency. As you can see in that table there, I have all the different notes that I will need in the song, I have all the frequencies listed, and I have all the lengths listed there as well. And now you will hear a summary from Matthew Patton.
Thanks, guys. And there you have it. This is how Team 7 is going to create 3 instruments that will fit into a 2 foot by 2 foot by 2 foot road case. Combined, they will not exceed 10 linear feet of pipe, nor 6 linear feet of string. Each will be tuned to present a different voice, and all this will be done for under the $15 allotted budget for each instrument. Thank you, and good luck on your projects.